Hi Doctor, I'm Lim Bao Ren, and today I'm going to talk about the scalability on real-time forest fire detection and monitoring. I'm from Section 1 Real-Time Software Engineering. So today we're going to introduce what is real-time embedded system. Actually, the real-time embedded system is we use the design and construction constraint impacts the surrounding system and also interact with the physical environments to ensure the specific action is effectively completed. The most important thing is he ends in a predefined amount of the time. So actually we have two kind of embedded system. One is single processor embedded system, next is multiprocessor embedded system. So actually single processor means that he use one processor and multiprocessor means that he have used two or more processing process. So actually the multiprocessor embedded systems, they have two kind of approach. They're using symmetric multiprocessing and asymmetric multiprocessing. So actually what we have been used in this project, actually we are using single processor since we need some things that less throughput, and we also hope that we don't have any integrations is favorable for this project. So next, what is our project? Our project actually we are calling real-time forest fire detection and monitoring. So we have 5 concurrent tasks: detect flames, detect temperature, detect fog, detect position, and predict forest fire. So we hope that we can use the minimum voltage to complete the task within the deadline. So actually we compare the two suitable algorithms to use. One is the rate monotonic scheduling and second is the earliest deadline first. So actually the objective for our project actually to find the best algorithm for this project, where we compare the earliest EDF and the rate monotonic RMS for the process utilization. So before we can prove that, we must do the scalability analysis on the both algorithm. So scalability analysis, what it means that scalability analysis is the evaluation and analysis of the algorithm for the real-time scheduler system. So actually it can be if the algorithm can be scalable, it means that the task accepted by a real system, task also executed within the deadline, depends on the scheduling algorithm. So we have introduced got 3 tools here. First is MASD, where is the modeling and analysis suites for real-time embedded system. So it's established a models to represent the timing behavior of a real-time system intended for the scalability analysis. So it's also one of the tools that offers an open source collection of tools to performing the scalability analysis or timing analysis. The next tools that will be introduced is SEDA. SEDA actually what is special is he used the AADL or the Cheddar architecture designs language to describe the system that have been analyzed. So the tools that have been used in this whole project, actually we use the TIMES tool. So TIMES tool actually stands for Tools for Modeling and Implementations of Real-Time Embedded System. So it also modeling, scheduling analysis, and executable code creation tools. So it is suitable to collect the actions that have been periodical or sporadical triggered by the passage of time or outside the events. So this is the samples that have been done for this using the TIMES tool. So what is task scheduling and chronicizing for the multi-core? Actually, this is the problem statements that have been faced in our paper 1. So the first research paper have been shown that we need to optimize the problems which identify a workable task to reach the minimum energy consumption. The real-time task is scheduled and synchronized with the access of the resources on the multi-core DVFS process. So actually, the main focus for this paper, actually we need to decide the execution speed of the task. The task can meet their timing requirements and the energy consumption is minimized. So the next paper also focus on the same things. Similar things, they also need to have a discrete speed with minimal energy consumption and support the DVS technique. So actually we found that we have 2 approaches here. The first approach is the scalable analysis for EDF and SRP. So for this is the advanced method from our slides. So our slides, we don't have the BI over TI. So BI over TI means that there is a blocking time for the processor. So for the BI means that the blocking time for the processor, and the TI is mean the computation time for the processor that have been blocked. So we also had another enhanced scalable analysis for PEDF and MSRP. This formulas is not so well for use in this project since it is more suitable for the multiprocessor. And what we have been done, we are doing a timeline diagrams, and we shows the periods and WCRT for the real-time forest fire detections and monitoring. So we have been seeing that we have one issue here where predict forest fires has exceed the UI is more than the UN. So it is not scalable. It's proof that this process utilization is not scalable for the rate monotonic scheduling. And the concurrent task timing requirements, if we change to earliest deadlines first. So where we can see that the all have been fulfilled the task since the all of the UI does not exceed 1. So it means that the earliest deadline first is schedulable since all the tasks can fulfill the UI. So for the discussion, actually we compare these two things up. We think that the earliest deadline first is more suitable for this system since it has to fulfill the schedulable analysis. And also the same where we found that rate monotonic scheduling, they have 5 conditions here where it need to all processes run periodically on a single CPU. There are no data dependency between the process. This is not valid for this project. Actually, we need data from the sensor and we need to analyze the data from the sensors. And the next is the execution time for a process is constant. However, this is not, we cannot confirm the predict forest fire since this forest fire is depends on the neural networks that have been analyzed the sensor data from the to analyze the sensor data. And all the deadlines are end at the periods. Yes, this is yes, and the highest priority ready process is always selected for the execution. So that's all for our presentation. Thank you very much.